Lesson 4.1 is going to focus on slope-intercept form, and in particular, writing equations in slope-intercept form. And we've already talked about slope-intercept in Unit 3, but we really focused on using it to graph and kind of using it to identify those really key characteristics about a linear equation. And today it's really more about really the equation and getting really good at writing that equation from lots of different types of information. So really quick review, slope-intercept form, right? This slope form right here is probably the oldie but goodie, also our favorite, y equals mx plus b. And again, we call it slope-intercept because at a glance, when it's in this format, it very easily gives us the slope just by looking at it, and it gives us the y-intercept just by looking at it, which is really cool news. So in slope-intercept form, the m is always the slope, the b is the y-intercept. Okay. So just remember, this format is always when it's that y is isolated and everything else is on the other side. If it's a linear equation, it's going to have this type of form where the coefficient in front of x is your slope, and then the constant that's by itself is your y-intercept. And as long as you understand that, you should be able to write the equation given the slope and y-intercept. That's pretty simple. Given the slope and just another point on the line, you should be able to write the equation by just looking at the graph. Or even if you're given 2 points, and I'm not sure why this didn't print here for me. Hopefully it did for you, but if not, write it down. So as long as you have an ordered pair and a second ordered pair that are both on your line, you should be able to write this equation. Or if they give you the same information, but instead of in the ordered form, ordered pair form, they give it to you in function notation, you should be able to write that equation. So let's go ahead and jump right in here. We're going to start off with the super easy ones here because they've already given me the slope and the y-intercept. So if you have been around for the last couple of weeks, or especially from last year, this should be very simple, because if they just hand you on a silver platter that slope and that y-intercept, then you know that they are essentially giving you the value of m when they give you the slope, and they're giving you the value of b when they're giving you the y-intercept, and then it's just a matter of inserting those where they belong. So in this case, this is the format, and for this particular equation on number 1, the slope would be a -3, so that's going to go right in there where the m was. And the y-intercept is a 7, which is going to go right there with the b was. So it doesn't get quite, a whole lot easier than that, to be honest. Okay, try number 2, see what you get for that one, and then you can check your answer. And on this one, the slope was 2, the y-intercept was -3. So if we put that into that slope-intercept form template like they asked us, this equation would be y equals 2x minus 3. So if you got that, you are in good shape. Okay. So those are pretty simple. Now let's talk about what if, so that takes care of sort of this format, right? That's the easiest. What if they give us a slope and just another point that we know is on our line, but it's not necessarily the y-intercept? Let's talk about how we might tackle that. Okay, so this time they gave us the slope of the line, so we still know m, and then they tell us that it passes through the point 2, 6. So they're giving us an ordered pair, but note that this is not the y-intercept. Not only is it not labeled y-intercept, but we should know that that y-intercept is always, against a 0. So in other words, if I wrote that as an ordered pair, it would look like that, where x is 0, and here x is not 0. So this is definitely not the b value, but we can still make this work. We will need b, but I'm going to show you how to find it. Okay, so if we know the slope and a random point, then we're still going to use slope-intercept form here. And what we're going to do is we're going to fill in what we know. So we definitely know the slope, right? Just like we did here, I could go ahead and insert that now. And then I do know that it passes through the point 2, 6. So what I'm going to do is I'm going to borrow that ordered pair and insert it as x and y, because any point on my line is a possible x and y. So I'm going to say, you know what, I know the slope is 4, so I'm going to go ahead and put that in for m. I also know that when x was 2, the result or the output was 6. So notice I took that x coordinate of 2, and I plugged it in for x, and that y coordinate of 6, I went ahead and put it in for y, and I filled in these guys temporarily so that I can solve for what b is. Okay, so now it's just a matter of solving this one-step equation. 4 times 2 is 8. We'll always simplify first before we proceed, and then once I have it like this, I can move the 8 to reveal what that what that y-intercept was. So that leaves me with b is equal to -2. So there's our b value. Now don't forget, that's not your final answer. We wanted to write our equations. So once I find b, I can go back to the original. I don't need that borrowed point anymore. Thank you so much for helping me out, but you're dismissed now. I just need the slope and that y-intercept that we found, and there's the equation of that line. So if they don't give you the y-intercept directly, but instead they give you a point that it passes through, use that point, borrow it as your x and y so you can solve for what b is, and then you can write your equation. Okay. Again, I'm not really sure why these didn't print out for me. Hopefully they did for you. This should be a -1/3 here. I'll do one more example just like that. They gave me the slope, so that is the value of m. They also gave me this other point. It's not our y-intercept, but it's a point I can borrow. So we're going to borrow that in there, and we're going to insert it into that y equals mx plus b. Okay, and then let's go ahead and insert what we know. We know that the slope was -1/3. We also know that when x was 1, the output or the answer was a -2. So if I fill in that x and y and that m, I can find b here. Okay, so let's finish this one out. -1/3 times 1, it's going to just stay -1/3. And then to get b alone, I'm going to do the opposite of that, which is add 1/3. That cancels. Okay, so b is going to be whatever this result is. Well, it just so happens that -2 plus 1/3 is -5/3. You can do that on your calculator. You can do a common denominator. But that is when you do -2 plus 1/3, and you can do that on the calculator, like I said. So if we grab here, we say, I'm going to start with a -2, and I'm going to add 1/3. There's my 1/3. You'll see you get that -5/3 right there. Okay. So once I know what b is, I can write my equation. My equation now is just y equals. I go back to my y's and x's. I just borrowed those. The slope is -1/3, and now I know that my y-intercept is -5/3, and there it is. Okay. So hopefully you could hopefully do that in your sleep, so easy. And then here, if you're given a point that's not the y-intercept, you can still plug it in, use it. So it takes care of that and that to find the equation. Let's talk about from a graph. So from a graph, if you know what you're looking for, it's almost as easy as the first two. Okay, so again, our goal, anytime we're trying to write slope-intercept form, we will need the slope and the y-intercept. So our goal will always be find m, find b. Okay, that's always going to be our goal. Now, m is the slope, right? So in a graph, I could use the graph itself to find the rise and run. From one point to the next, how much do I have to move vertically, and how much do I have to move horizontally to get to the next point? So this is a very deep negative. In fact, as soon as I see that that is a downward line, I might go ahead and take care of the negative so I don't forget it later. And then if I go from this point to there, I have to go down 1, 2, 3, 4 units down and 1 unit forward. So that's a slope of -4/1, or in other words, just -4. There's our slope. B is always the y-intercept, so that is where my graph is intercepting the y-axis, and I can actually see that point right here, and it's labeled right there. So my y-intercept is -1. And if you can pluck those two really key pieces of information, you can write your equation in slope-intercept form by just inserting that m value as your x and that b value as your, not as your x, but in front of your x, and then that b value as your constant. Okay, so that's the equation of that particular line. Let's do this one together actually. Again, we need to find the slope, so I'm going to look at my 2 points and calculate what is my rise over run here. So this is a positive line, and I'll go up 1, 2, 3. I'm going up 4 units every time that this goes 2. So 4 over 2, that's your rise over run. So for our M here, it's 4 over 2, or in other words, just 2. There's our slope. Our B is a y-intercept where it hits the y-axis, and that is happening right here at 0, 0. So we have a B value of 0. In fact, since this passes through the origin, maybe you're catching on that this is actually an example of direct variation. But either way, we can now write our equation, y equals the slope we found times x, and then we could put the plus 0, but since it's 0, we typically just drop that and we just write it like this. Try number 7. Give it a shot, and then see if you can come up with the equation from the graph there. Okay, so check your answer there. If you got a slope of 1, because here from this point to this point you go up 2 over 2. 2 over 2 is 1, or maybe you picked this point, and maybe you went up 1 over 1. Either way, it's a slope of 1, and then your y-intercept is right in here. It goes through y equals 1, so that's your y-intercept. And you could write 1x plus 1, or you could just write x plus 1. They're both equivalent, and that is your equation. Okay, so that's being able to write slope-intercept from a graph. Let's talk about the slightly more complex ones where we are trying to come up with that information, but from 2 points. So our goal is still the same. Our goal right now is to write the slope-intercept form, but we haven't been given either of the ingredients that we need. So I'm going to make myself a little reminder of what I'm always after here. This is our goal. So what we will always need is the slope of that line and the y-intercept of that line. Just a little reminder. We had that on the front, but since we turned that page, it's good to have it there. Okay, so we want to be able to write that from just 2 ordered pairs. I don't have a graph in front of me. I was not given the slope. I was not given the y-intercept. I've got to do all of the work for this, but it's not too bad. So from 2 points, usually the easiest place to start is with the slope. So let's start with that. Do we know how to calculate, since they didn't just hand it to us this time, do we know how to calculate the slope from 2 points? Well, yeah, we do, right? So a little reminder that if they weren't nice enough to give it to us, we can find it using the slope formula. So as long as I have 2 points, we can use that formula right there, the slope formula, to find M. Okay, so I'm going to designate one of these as my x1, y1, and I'm going to designate the other one as my x2, y2, and I can just drop those right in to that slope formula. Calculate the slope, and then it'll be a lot like what you had on the front page. So let's start with slope here. So the slope, remember, is y2 minus y1 over x2 minus x1. So in this case, that means 4 minus that negative 1 for my y's, and then on the x's, it would be 8 minus the 3. Which is fine. Now, when we have a double negative here, it becomes a positive. So you recall that. It becomes a big old plus. So we end up with 4 plus 1, which is 5 in my numerator. On the denominator side, 8 minus 3 is also 5. So we end up with 5 over 5. Well, anything over itself is just 1. So now we know the slope is 1. Okay? Once you know that, and you realize, oh, I know the slope now, right? I know my slope is equal to 1. I have 2 points. This really becomes exactly like problems 3 and 4 on the front page, okay? Where we know the slope and we have some random point. It's on our line. It's not that random, but it's not the y-intercept, right? But we have a point that we can borrow to find B. So most of the work is done when we found M. Now all I have to do is borrow either one, and that's kind of cool. It doesn't matter which one I pick, as long as it's either one of these 2 points, because I know that those points are both on the line. So I'm going to use the 8, 4, but you could have done the 3, negative 1. In fact, I may encourage you, a lot of y'all, to try that one. You're going to see you're going to get the exact same equation because they're both on the line. That's the point. So this is our borrowed sort of xy. We have our M, and now we can drop those into slope-intercept form to solve for B, which is the second ingredient that I need. I needed slope and I already found it. Now I need y-intercept. So let's plug in what we know. So in this case, when I borrow this ordered pair, y would be 4, my slope is 1, and x would be 8, and I'm looking for b. Again, you could have used the other point, it would be equally accurate. Okay, 8 times 1 we know is just 8. And then to solve for b here, we know we're just going to subtract that 8 on both sides. So 4 minus 8 is just a negative 4. So b is equal to negative 4. Now I have the two ingredients I needed all along. I have my slope, I have my y-intercept, and now I can write the equation of this line. So the equation that passes of the line that passes through those 2 points is y equals a slope of 1x, or just x, and then a y-intercept of negative 4. So there's our equation. And again, if you wrote 1x minus 4, that is perfectly okay. Okay, perfectly okay. All right, let's try another one like that. I'm going to create a little separation here so we don't get too jumbled up. Probably need a little more space there. Okay. Again, let's try number 9. On number 9, we are going to have to use the slope formula because they did not give that to us. So we'll designate one of these as our x1, y1. The other one will be our x2, y2. We'll plug those right into that slope formula. I'm going to go a little faster here. You know where the formula comes from. So 5, that's my y2 minus y1. In this case, it's 5 minus 1. My x2 minus x1 is 3 minus 2. So when I calculate that, I get 4 over 1, or a slope of just 4. That's our slope. Okay. So now I know my slope is equal to 4, and now I can borrow either one of these points. It does not matter which one I borrow. Maybe I'll do the first one this time. Sure, the 2, 1. And we plug those into that slope intercept. So when I insert that as my m, my x, and my y into y equals mx plus b, this is what this looks like. Y is 1, slope is 4, x is 2, and we're solving for b. And then 4 times 2 is 8 here. And when we finish off solving here, we'll have to subtract that. And we get 1 minus 8, which is negative 7. That's the value of b when we solve this. Okay, and so now that I know, oh, there's my two ingredients I needed, m and b, I can write the equation of this line. We've got y equals 4x. Now we go back to our x's and y's. I'm just using my slope and my y-intercept to write my final equation. There it is. Okay. Try number 10 and see how that goes. Okay, so first of all, check your slope that you got that correctly. Regardless of which one you made your x1, y1, you should have gotten a slope of 1/4 here. So that's our slope. Now, normally the next step would be to borrow one of these points, but if you're paying close attention, right, and if you were kind of alert on this, they gave you the b value. They did actually give you b in this case because, remember, b is always a y-intercept, and that's always when x is 0. So this is already the y-intercept. They give us a little gift here, and we didn't have to work too hard for it. So that is your y-intercept, and that means we don't have to necessarily go through this process of borrowing to find b. If you were, like I said, if you were kind of alert and awake on this, oh, there's my b right there. It's 2, so we can actually jump right in. Now, if you plugged it in, it's not the end of the world. You should still get this answer. Either way, whether you plugged it in, and if you didn't catch it, if you actually worked it, that shouldn't make any difference. Your y-intercept is always your y-intercept, right? In this case, it is 2. So that is the equation of the line, whether you found the loophole or the little shortcut there, or whether you did it the more traditional way of doing it. That's your equation. Okay, what if they give you ordered pairs but written in function notation? Does that make any difference at all? The answer is no. Okay, so there is literally no difference between 8, 9, and 10 and what they gave you there, and 11, 12, and 13. They're giving you the same information. They're just doing it with function notation instead of ordered pairs. But the idea is function notation is giving you the same information. So when I see f of 6 is negative 2, what that is telling me is that when our x input was 6, our y input was negative 2. So if you want, you can even rewrite those if it kind of bothers you to see it this way. And you'll notice they're really doing the same thing as on the first three. So when they tell you f of 4 is -3, what that's saying is that when they inserted an input of x equals 4, then the y output was a -3. So again, they're really just giving you two ordered pairs that are on your line. The rest of this is history. You treat it exactly like you would 8, 9, and 10. Okay, you would find the slope using the slope formula, and then you would write the equation of the line. So I'm going to start here. I want y'all to try this one on your own. Find the slope first on your own and see how you do, and then we can see the equation. All right, so check your slope here. When we do the way that I did it was -3 minus a -2. Don't forget that minus a negative becomes a plus. So it's -3 plus 2, which is -1. And then on the x's, 4 minus 6 is just -2. When we have a negative over a negative, you got to remember that really becomes a positive. So our slope here is a positive 1/2. So hopefully that is what you got. And then once you know that, you can use that and either one of these points. It does not matter which one. I'll go with the 4, -3, but you could pick either one. And let that be your something borrowed, right? Your xy to throw into the slope-intercept form. So what I know here is that y was -3 when my slope was 1/2 and when I plugged in a 4. And that's enough information to solve for b like we have been. So 1/2 of 4 is 2. And then to solve that, I'm going to come up here where I have more room. All I have to do is subtract 2 on both sides. Now a negative combined with a negative actually gives us a sum of those negatives. So that's a -5. So our function f of x, now I can go back to my original mx plus b. They're using function notation, so I'm going to be consistent with that and use f of x instead of y equals, but it's the same thing. So y equals or f of x equals our slope that we found times x, and then our y-intercept. So y equals 1/2 x minus 5, or even better yet, since they're using function notation, f of x equals 1/2 x minus 5. All right, so hopefully that gives you enough information there to really be able to write the equation in slope-intercept regardless of what combination of data you are given. So now let's put this in the context of a word problem. A linear model, so go ahead and write that down. A linear model is simply a linear function that models a real-life situation. So anytime that you have a real-life scenario that can be modeled with a linear relationship, okay? If your quantity changes at a constant rate, increasing or decreasing at a constant rate, with respect to x, then you can use this format any of those times, right? Of course, m is always a constant. Remember, we talked about slope, but now we're talking about like in a real-life situation. So on a graph, m is your slope. In a real-life situation, that m or that slope really tells you what is that rate of change. How much is that variable increasing or decreasing? And then b, where typically that's our y-intercept when we're looking at it on a graph, the value of b is like the initial quantity or the starting amount that you began with. Okay. So with that said, let's see a couple of examples. We're actually going to leave 14 for class, so skip to 15. Let's do this one together here. So if you look at number 15, it says an electrician charges $120 after 2 hours of work and $190 after 4 hours of work. We want to write a linear model that represents the total cost as a function of the number of hours. So we want something that where the output is the cost, right? So if we're thinking in terms of that y equals mx plus b, we could use x and y, or we could say the cost is a model of the number of hours that the person works. So write in a linear model that represents the total cost. That means our output is the total cost as a function of the number of hours worked. So our input is the number of hours, right? So whether you use C and H or you use X and Y, it's the same relationship. They want you to write a linear model. So it should fit that y equals mx plus b. Now, they did not give us the rate of change. They didn't tell us how much the person charges. They didn't tell us an initial amount. But they did give us sort of two pairs of information. They said that for 2 hours of work, the cost is $120. And they told us that for 4 hours of work, the cost is $190. So that's like giving us 2 ordered pairs. Starting to look familiar? I hope so, right? It's exactly what we just did. It's just in the context of a real life situation. But you can start to see how this is just like this work that we just did. If I have 2 points, I can completely unravel the rest of this kind of mystery and find everything I need. Okay. So let's go ahead and find this model. From 2 points, we need to find the slope first. So let's start with that. Slope is going to be the change in our y values over the change in our x values. Okay, so from 120 to 190, that difference is 70. And from 2 to 4, that difference is 2. And so that's 70 over 2, or in other words, 35. So that is the rate of change, or the slope if I were graphing this. But in this case, it's the rate of change. It's how much we're charging per hour. So this is cost and then hours. So it's $35 an hour. So there we already are unraveling, that rate of change, if you will. And then let's talk about the y-intercept, right? So how do we find that? Well, we can borrow one of those points and say, all right, well, I know it's $35 an hour, and I know when they did 2 hours worth of work, the total was $120. So let's find out what b is, what that y-intercept is. So we borrow a point and the slope we just found, and we calculate b. So if I simplify that, that's 70. And then if I solve for b, I subtract that 70, and I get that b must be 50. Okay, so that is the initial quantity, or the initial amount. So if I'm going to write this function now, right, I can say, oh, basically the cost here in terms of number of hours is $35 an hour plus that $50 initial quantity, or initial amount. So there is our function, what they wanted, the linear model here. So what is the electrician's initial fee? That's your starting quantity or initial amount. So in this case, her initial fee is $50. Looks like that. An electrician will charge $50 just as a flat initial amount. And then how much does the electrician charge per hour? That's your rate of change. So initial quantity and then rate of change. So in this case, her hourly rate is $35 per hour. Okay, so that slope on a graph in a real life situation is your rate of change, or how much that steady increase or decrease is. In this case, it's $35 for every hour worked. And then the y-intercept on a graph for a real world problem is usually the initial amount or the starting quantity that you began with. So there you go. All right, guys. And then we'll finish number 16. We'll probably do 14 and 16 as warm-ups in class.